So good morning, everyone. This is Chen from Sungrow speaking, and so I'm very happy to have this opportunity to have this webinar with you today. So, and I found today we got 4 friends to join this time webinar, and Arun Zhang, Alan Smith, Lawrence Chow, and Vajra Sharma. So welcome, and so we don't got many people today, so please just be casual for this webinar. If you have any questions, please just we'll have a Q&A time. Please just write the questions, and after the introduction of this presentation, I will answer your questions individually. So if anyone can't hear my voice very clearly, or you have any questions, please just write your comments. So let's get started. So first, I would like to have a brief introduction of myself. My name is Bob Chen, and I'm from Sungrow Power Supply. And Sungrow is a company. We are dedicated in the green energy industry, and we are the manufacturer for PV inverters, and we also have some products for wind converter and also for EV controller for electrical vehicle. And we also do some floating projects for solar projects. And so regarding my department, for system solution department, so we're engaged of the technical support of the application of the PV inverters. So basically, we will contact with our customers, the EPC, the developers, regarding the technical solutions for your projects. So, and I also I'll write my email address here if you have any questions about our product, or if you have any questions about your further projects, please don't hesitate to contact us. So regarding this time, the webinar, we will introduce our new inverter, SG250HX, which is a new string inverter, and I think it will be the largest string inverter in the industry. And this inverter is under process of testing and design right now, and because Sungrow has very strict requirements for the test before releasing it to the market. So we need around one or 2 months to go to finish the test of these inverters. So I think we will finish the testing around in September or October. So so you can contact our commercial manager in your regions, and so that you can purchase our inverter maybe in September or October. So regarding these presentations, they are divided in 5 parts. So first part, we'll introduce some leading technical tendency in this industry, in solar industry. And second and third part, we'll introduce the CAPEX, the initial investment, and also the operation and management savings. And in the first part, we'll introduce how this inverter will increase your power generations. And last part, we'll introduce some reference for Sungrow inverters. So let's get started. So, and we all know that in the past 5 years, so the solar industry has been changed a lot. So, and maybe 5 years ago, every person will think that solar industry is power generations that were very expensive compared with other traditional power generations. And maybe solar industry relies on the policies from the government a lot. Otherwise, it can't compete with other power generations. And so, but now the situation has been changed a lot, because in many countries, the price of the solar power has been similar or even lower than the other generations, like the traditional coal power and also the gas power. So actually, in some regions like India, now China, and the Middle East, the solar power the price has been very low in these countries. And so with the lower price of the BOS cost for building up solar stations, at the same time, the developers of the solar industry has faced a lot of pressure from the PPA price, because for PPA, the PPA price has also been changed a lot in the last 10 years. I attach a table here you can see on the screen. So with the time modes, the PPA price has been changed a lot. So you can see from this timeline, the solar industry, now the PPA is much lower than the 2008, 10 years ago. And with the lower PPA price, every developers, every EPC, they need to build a power station that has a POS cost at the same time, and easy for operation and maintenance at the same time. And finally, they need to have a good power generations. Otherwise, their investment can't be got back. And this formula introduced how to calculate for the system LCOE. First question: what is LCOE? LCOE is the levelized cost of energy. So in general, it is the price for every kilowatt hour energy you got. The lower of the LCOE it is, the easier for you to get your investment back. So, but how to calculate the LCOE? We can see from this formula, LCOE consists of these factors. First is CAPEX. CAPEX, maybe in other articles, maybe it is called by BOS cost, initial cost of the system, and so it consists of the components of the devices cost of the system, and also your cost for developing solar station, including the investment for financial, for getting a PPA. So all these are CAPEX. So we can see here we split into the device cost into different items like the inverter cost and also the PV block cost, like the PV module cost, and also the cable cost, etc. And we can see here, so with the high requirement from the LCOE, the inverter capacity has been changed a lot. Maybe 10 years ago, a 50 kilowatt inverter, now it has the same size of the 500 kilowatt inverters. So the inverter capacity can be larger and larger, and so we can have a larger block size. So in conclusion, the larger of the block size is the lower of the LCOE you can get. So even in some countries like India, we have seen some investors, they are using the 12.5 megawatt per block to lower the CAPEX. And at the same time, we also have some technology improvements to lower the CAPEX, like we increase the system voltage from 1,000 watt to 1.5 kilowatt, especially in the last 3 years. Many utility scale projects, they are using the 1500 watt system, especially in India, in Middle East, in USA. And we believe that the higher the system voltage is, the lower of the system cost, no matter for inverters, also for cables, transformers, and switchgears. This device's cost will be lower if you have a higher system voltage. So this is the reason why some specialists is discussing increase the system voltage of the solar projects. Maybe in the next 5 years, we can see some 2 kilowatt DC system in the industry. So let's see. And at the same time, the OPEX is the operation and maintenance cost for the system, because normally for the PPA, so for every developers, they need to sign a PPA with the grid company for 20 years, even 21 years. So the operation and maintenance is very critical, because the devices in the system need to have a very high reliability. Otherwise, if every day has many failures in the system, you will find it, you need many human resources and many times even cost for the components for doing the maintenance for the equipment that is broken in the site. So the reliability is very critical for a system, for a device manufacturer, no matter for inverters, but also for cables, transformers, and the PV modules. And at the same time, the devices of the system or the power station need to be compatible with different kinds of environment. For example, maybe 10 years ago, it's very easy for finding a good land for have a construction of the solar stations. But now many countries, they have already installed maybe 10 gigawatts of the solar stations. So it's not easy for find a good land. So some projects will be located in a mountain project. So some projects near the sea, which is faced with the corrosion risk. So from the system level, it needs to be compatible with different kinds of environments, no matter near the sea or on the mountain, and even in some industrial areas. And the third point is easy for O&M. If a device is very specialized, is very complicated of the structure, or the their components in the system is very difficult to find in the market. So the O&M is very costly for the operation. And the last part is excellent grid support to make power station more stable and eliminate potential penalty from grid operator. Because what we see in many utility projects, the grid operators, like the grid company, they need to give some dispatch commands to the power stations, like the AVC or AVR commands. So, and each grid company has different requirements, but in general, all of them, they need to have a very good fast response time for the inverters, all for the power stations. So we need to have a very good grid support to support the grid. Otherwise, the grid operators will need to have a power limitations for the power stations that will cost your money back. And the last part will be the high yielding, because the higher of the power generation you can have, the more money you can get back. So how to get a high yielding for the system? First, you need to have a high efficiency. So it consists of different parts. First is the pure modules. In the last 5 years, the pure module technology has been changed a lot. So now we can see many new technology for the pure modules, like the PERC technology, and also many pure modules are using the bifacial technology at the same time. And also for inverter side, the inverter efficiency is going higher and higher. Now you can see for Sungrow inverters, our max efficiency can reach 99%. So that from inverter side, we can convert more power from DC to AC to get, and finally at the point of interconnection, we can get more money back. And for the cable losses, because for the system, so from the pure module to inverters, they are using the DC cables. From inverters to the transformer and to the point of interconnections, you have very long AC cables. So the lower of the cable loss you have, the more power you can get from the metering, the energy meter. And the third part is the compatible with high DC ratios, because previously many developer or EPC are designing projects with 1.1, 1.2 DC ratios, but now with the price of the pure modules has become lower and lower. They are designing the DC ratio higher, like 1.5, even 1.6, to make the power station to work at the full power for longer times, because normally the PPA is signed with the grid operators with the AC side capacity. Maybe, for example, you have a 10 megawatt project, is defined at the AC side. So no matter how much DC power how much pure modules it will be installed, the grid operators they can accept. So the more pure modules you have, the longer of the power station can work with the full power. So this is the reason why many operators, why many developers, they are designing with 1.5, this kind of high usage ratio. And the last part is decrease the power loss of the pure modules, because although we are not a pure module manufacturer, but we know that for pure modules, they are degrade every year. So maybe for first year, you will have a LRD phenomenon, and you will have around 1.2% of the power loss. And with the time goes, you will gradually lose the power every year. So the pure module, they need to have a very good performance for the degrading. Otherwise, maybe first year, you will have very good power generations. And second year, third year, the power generation will be lower and lower. So in conclusion, for LCOE, it consists of this kind of factors which will influence the system LCOE. So, and in the second, third, and fourth part of this presentation, we'll introduce from inverter part how to lower the LCOE. And this page introduces some key features of this new inverter, SG250HX. You can see here. So first is the efficiency. That's like we already discussed. The higher of the efficiency is, the more power generation you can get. The efficiency of this inverter is 99%, and European efficiency is 98.7%. At the same time, it has 12 MPPTs, and each MPPT has 2 inputs on the DC side. That means that we can connect 24 inputs from the pure module. We can connect 24 strings from pure modules to inverters. And The third part is the system voltage. We are using the 1.5 kilowatt technology on the DC side and 800 watt on the AC side to lower the cable loss and the system investment. And the first part is compatible with bifacial modules, because we know that for bifacial modules, the typical difference between single facial module is that the bifacial modules will have a higher short circuit current. For example, it will has 1.5, even 2 times of the single facial module of the short circuit current. So from inverter side, we need to design the inverter to be compatible with this kind of high current from PV modules. For each inverter for each post of inverter on the DC side, so we are designing the current capacity of inverter side is 26 ampere. So we can be compatible with bifacial modules. No matter how high the current is, we can guarantee we can work with bifacial modules. Actually, we already have some reference in China and in other countries that our inverter, Sungrow inverter, is working with bifacial modules together. We prove that we can work with them. And the fifth part is the anti-PID functions, because I know in this industry, now many PV module manufacturers, they are claiming that their PV modules is PID free. But we all know that no matter it's PID free or not, it will happen some PID phenomena in the site. If PID happens, they will degrade the PV modules from time to time. So in this way, from inverter side, we need to have some solutions for anti-PID. For central inverters, maybe you are using the negative grounding for anti-PID. But for string inverters, it can't be negative grounded, because for single transformer winding will connect many string inverters, maybe 20 numbers of string inverters. So it can't be negative grounded, otherwise it will have some short circuit in the site. So it's the reason Sungrow will have a patented anti-PID functions for string inverters to protect the PV modules from anti-PID. So in the below part of the presentation, we'll introduce for these functions in details. And the next point is DC 2-in-1 design to make the higher DC ratio, because we know that we have 12 MPPTs and 24 inputs for the DC connections. So maybe some designers they are design the 1.5 DC ratios in the site. So you will find that with 24 inputs, they can't have the 1.5 DC ratio. For becoming the compatible with the higher DC ratio, we can use Y connectors. That one connector of the inverter side will has a Y connector outside of the inverter, so that one connector of the PV inverter side can connect 2 strings and at the same time. In this way, by using the Y connector, the inverter SG250HX, we can connect 36 PV strings at the same time. I think it can cover most requirements of the power stations. And next point is the PLC communications. So what is PLC? PLC is power line communication. Maybe traditionally, the string inverters are using the RS-45 connection, use a DC chain to do the communication. So in this way, you need to invest some communication cables in the system. But by using the power line communication, we can integrate the communication data in the power cables, so that we don't need RS-45 cables. We can save some cost for the communication cables. And next part is string level monitoring and online RV curve scanning functions, so that we can make the O&M of the system easier. And the next part is the grid support part. We can compatible with Q&9 functions and adjust the power factor from 0.8 lagging to 0.8 leading, because in some grid codes requirements, it needs the inverter, it needs the power stations to output some rated power at night to support the grid. So inverter side, we need to be compatible with these kind of requirements. And the last point is IP66 protection and C5 anti-corrosion, because in some areas, like in the desert, near the sea, it will have some critical, it will have some potential risk of the anti-corrosion or some water ingress or dust ingress. So it's the reason why inverter we need a very high IP level and a very high C5 anti-corrosion level. And this is the first chapter, and the second chapter will introduce how the inverter will lower the system CAPEX. And this is typical system architecture of the SG250HX string inverter. You can see from left side, so left side is the PV modules. Every strings will connect to the input of the string inverter. Of course, you can use the Y connectors to have a higher distance ratio. And in the in the middle part between the PV modules and the transformer is the inverter. And we have the 12 MPPTs. And here we need to note that we mentioned 225 kilowatts because for this inverter, the max power is 250 kilowatts, and the nominal power is 225 kilowatts at 40 degree. And we can also be compatible with two-in-one design or Y connector design. And from the inverter to the transformer, it's use the PLCC power line communication to save the cable cost for RS-485 cables. At the same time, we can from the transformers to the SCADA system or the control room of the system, we are using the fiber optic cables. You can see here we have a CAM100 here. CAM100 is a box, auto box, which integrate the data logger, the power supply for the data logger, and also fiber optic switch inside of it. In this way, for CAM100, it will get the signals from inverters to transformers by PLC technology, and it will convert the data from inverters to fiber optics and send it using connections between block to block, send it to the SCADA systems. And please note that for CAM100, you can not only get the data from inverter part, as long as other devices are using the Modbus protocol, we can gather all the data from them. So no matter it's transformer, switchgear, or combined box, or base station, all of them we can use the CAM100 to monitor it and send it to SCADA system together. And for Sungrow side, we can package solution for inverter and MV solution. So here we see a container. So it's a 20-feet container which integrate with the LV switchgear, with the MV transformer, and MV switchgear. So all of them we can package solution and send it to the site. So in the site we can achieve plug and play. We just install the transformer in the site. The internal connections between LV switchboard to transformer, from transformer to switchgear is already assembled in Sungrow workshop, so that we can save the time in the site. And on the right side, there's control and monitoring part of system. One thing here, it has local SCADA for the PV block, and we also have some remote SCADA for the HV station, like 132 or 110 kilowatt stations. And we also have a PPC, power plant controller. So PPC will be the interface to receive the commands from the grid operators. So if our grid operators send a command to the power stations, they will send it to the PPC first, and PPC will do some internal calculations for each inverter, how each inverter should be respond to the commands from the grid operators. And PPC finally will send the data, send the commands to each inverter, and inverter will operate according to the PPC commands. And this is the signal line diagram of the PV block. So for Sungrow, if we pack solution for the MV containers, we can maximum provide 6.3 megawatt solutions, and the 6.3 megawatt solution is integrated with 28 members of SG250HX. And from left side is the PV strings and 28 PV inverter. Each inverter AC output will connect to the AC switchgear LV switchboard. We can see here it has 28 inputs of the LV switchboard. Each LV switchboard will has a MCCB which 250 amperes, 800 watt on the AC side. And after the LV switchboard, it will have ACB, two ACBs to be installed to protect the LV switchboard between each 250 ampere of the MCCB to the transformer LV side. In this case, if any short circuit happens from transformer side, the ACB can protect it. And in the middle is the transformer. So the transformer, we can we can design the LV voltage or the MV voltage according to the system voltage, because different country or different grid company has different voltage for the system levels. Maybe some areas you are using 22 kilowatts, some areas you're using 33 kilowatts. We can design the transformer according to the local grid requirements. And in the below part is the auxiliary power supply, because in some sites you need some power supply for like trackers, for some CCTVs, lightnings. So you need some auxiliary power supplies. We can configure the auxiliary transformer according to the site requirements. Our standard configuration is 15 kVA, and the maximum capability is 40 kVA, 40 kVA. For normally 15 kVA, we can cover most site requirements. But if you have a higher requirement for auxiliary power supply, we can discuss case to case. And on the right side is the switchgear or the RMU for the system. So, and normally we're providing the CCV type, the switchgear, and we're cooperating with some OEM like ABB, like Siemens. They are our supplier for the switchgear. So we have different voltage levels for the switchgear, like the 24 kilowatt or 36 kilowatt. So you can select according to the system voltage in the site. And we can also see a CAM100 in the system. So it will get the signals from inverters and also transformers and switchgears and send it together by fiber optics to the SCADA systems. And let's come to the next page. Is a system typical system arrangement of the system. You can see here each inverters, 28 numbers of inverters will be installed at the under the PV modules. So normally it will be distributed allocations in the system, and finally it will the MV container will be located in the middle side of the PV block, and also listed what's the quantity for inverters, what's the quantity for PV strings in the system, and what's the rack design. So if you need this kind of information, please send an email to us. We can send you this drawings for your reference. And we also do some comparison between system block from this inverter to another power capacity of the inverter. So some friends will ask why Sungrow is designing the inverter with 250 kilowatt rather than 200 kilowatt or 185 kilowatt, because we want to have a larger inverter capacity to lower your system cost. So here, this page, we introduce how 250 kilowatt inverter will save the system cost rather than the 185 kilowatt inverter. So in general, for 100 megawatt projects, the 250 kilowatt inverter can save your investment with $0.25 million compared with 185 kilowatt inverters. Here we also split how much power, how much money you can save from each part of the system. Here we can see for the inverter side, we can save 0.15 cents per watt from inverter side, and as well as the transformer and command box for AC command box, also will save 0.15 cents per watt in the system. And the cable side, from the cable side, we can save 0.22 cents per watt in the system. And in this page, we introduce how inverter can be the power supply for the tracker systems, because we see that now more and more projects are using the trackers, especially for some power stations that's in the north regions. The solar irradiation is not very good, so you need a trackers to adjust the PV module orientations to have a direct contact with the sunshine. So in this way, in some traditional designs, they need to have some additional power supply to the motor of the tracker systems. But for Sungrow, this inverter, our SG250HX, we have a power port that we can connect the trackers directly to our inverters, so that you don't need to some additional or separated power supply for the tracker system. You can save this part of cost. And in this page, when we do some calculations, how much money you can save. from the tracker power supply. We can see here, we can save $0.22 million in a 100 megawatt project. And this $0.22 million is integrated with the cable cost and also the cost of the power supply of the motor system. We can see here how much, what's the length of the cables in the system. And after we are using the integrated power supply solution that makes the inverter to be the power supply system, what's the cable length and how much cable we can save in the system. So in conclusion, so $0.22 million is consist with the cable cost and also the power supply cost together. And we know that the ESS, the energy storage, is a very hot topic in the world. So and many developers, they are finding some DC coupling system, because normally for BESS system you have two solutions. One is AC coupling, another is DC coupling system. So many people, they are looking for a DC coupling system to save the system cost, because DC coupling system has less quantity of the devices in the system. So it's a new tendency of the technology. And for AC inverters, we reserve ESS port in the system. We can see here in this SLD of the system, there will be some batteries on the DC side and use a DC-DC from batteries to the inverters. From inverter side, we reserve a port in our bus bar, so the DC-DC will connect to the inverter bus bar directly. In this way, our inverter can connect the PV module and the battery at the same time. And finally, inverter convert the power from the DC power from batteries and also the PV side together and send it to AC to the AC side. So that we can save some cost for some additional PCS for the ESS system and some additional transformers, switchgear in the system, make the system simple and have less content of the system. And I just want to make a note that for this inverters, so for stage 1, we will design the PV inverters. For next year, Q1, we will finish the design for ESS connections for these inverters. So next year, if we want a DC coupling system, please contact Sungrow. We can give you these solutions with SG250HX together. And we can also package solution for the DC-DC converter and also the batteries together. So for Sungrow, we have a JV, joint venture company, with the Samsung SDI. So in this way, we have two companies. One is Sungrow Samsung, we're providing the ESS PCS and also the DC-DC. At the same time, we have another company, the name is Samsung Sungrow. It manufactures the batteries for the system. So in general, Sungrow is not only providing the solar inverters, but also we can provide the ESS system solution. And let's come to the third part of the presentation. The third part will introduce how the inverter can save your OPEX. And first, like we already discussed, the reliability of the system is very important, as well as the inverters. So this is the reason why Sungrow inverter, we're all using the tier 1 level critical components in the system, like IGBT, like the inductor, relays, like the DC switch, and also like the driver board, PCB. But also, all of them are using tier 1 supplies in the industry, so that we can max our inverter to have 25 years design lifetime. And at the same time, we can have achieved 0.3 failure rate per year of string inverters. This year, 0.3% of the data we get it from our history data last year. We get it from our service department, our quality department. That last year in 2018, our string inverter failure rate is 0.3%. And regarding 25 years design lifetime, because normally for PPA 20 years or 21 years, so at least inverter should be designed have a longer lifetime than the PPA. So this is the reason why Sungrow we have a 25 years design lifetimes. And how to get this result of 25 years rather than 20 years or 30 years? Because we calculate each component of the inverters, and each component will simulate what's the working condition, what's the temperature, what's the current of the normal working, and we will check with the component supplier. So in this kind of condition, how long time will the component works? And after calculation of each component, we get the result of 25 years of the whole inverter working times. And this page gives some design of a cooling system for our inverters, because some people will ask why Sungrow inverters we are using the air cooling, because there are some electrical formula that if a component has a each 10 degree of the working temperature higher, the lifetime will be halved. That means that if a component is working at 20 degree, another component is working at 30 degree, the 20 degree components will have 2 times of the working time than the component which is working on the 30 degree. And we also do some tests that we compare some natural cooling inverters and air cooling inverters. What's the temperature difference between these two kinds of concepts? That we find that, so for some components inside inverter will have more than 30 degree difference of the working temperature. And according to this formula of electronic components, and you can imagine how short will be the natural cooling inverter of them. And so this is the reason why all Sungrow inverters we are using the smart air cooling. That because we want to have a longer lifetime of the inverters in the site. And at the same time, so some friends will ask why you are using the smart air cooling, that it will consume the power of the system. And but what I want to say that for Sungrow, we are designed with the smart air cooling. That means that the fan of the inverter is not always working at the full speed. They will automatically adjust its speed with the temperature of the inverters, and it means that at some cool environment, that inverter, the fans, even they won't work, it will only work at the hot temperature. So that the fan won't consume much power of the system. And regarding the fan lifetime, because some friends were also curious about why using fans will increase the possibility of failure of the inverters. First, our inverter, we are using the Tier 1 brand of the fan supplier. We are using the EBM, the fan supplier from Germany, and also the NMB fan supplier from Japan. Both of them are the Tier 1 supplier in this industry, and the fans, they are using the IP68 protection level, which is very high. That means that the fan can be immersed in the water for long times. So no matter the fan is working with in outdoor or indoor, the fans won't be influenced by the environment. And at the same time, in case of any fans failure, Sungrow will have a design of the fan replacement with plug and play. Each inverter can finish the fan replacement within 2 minutes. That we just detach the screw at the side of the inverter and detach the connector of the fans with the inverters, and we replace it with a new fan and put it back. We can finish the replacement with 2 minutes. So in general, our fan design won't influence the reliability of the system, and rather of that, the fan's design will increase the reliability of the system because the components of the inverter will work at a lower temperature for 25 years. And regarding the anti-corrosion and the protection level, because in some installations, inverters near the sea or in some industrial area which has a very heavy pollution. So in this way, the inverter is very, if the inverter doesn't have a very good anti-corrosion design, maybe the inverter enclosure will have some painting failure after 1 or 2 years. But we are designing the inverter with C5 anti-corrosion level, which is the highest level in the industry, because for anti-corrosion, it has C1 to C5 levels. C1 is lowest, C5 is the highest level for anti-corrosion. And for inverter, we also do some paintings for anti-corrosions, and we also do the same thing for the PCB for print circuit board inside inverter with some coatings for protect this kind of components from the dust and from the water, so that we can achieve IP6 protection level of inverters. And for some supply of the inverter, maybe it will suggest to install inverter in the indoor. But for Sungrow, we don't need to install inverter in the building. It's totally outdoor type. You can just install inverter inside the site. We don't need some additional house or buildings for installing inverters, so that we can save some cost for your system. And this part is the string level monitoring and IV curve scanning. So for achieve the string level monitoring, we have a current sensor in each input of the inverter side on the DC side, so that we can send each input data from the inverter to the SCADA system. And by calculation of these data, Sungrow we have some smart diagnosis of the SCADA system that we can diagnose some potential failure in the system, like the PRD phenomena or some other failures or risks from the PV modules. On the right side, we see how much kinds of diagnosis we can have from our SCADA system by using the DC side string level monitoring data. And at the same time, we also have some IV curve scanning functions, because after some years of the working of the power station, maybe the PV module has some degradations in the system. Some operators need to see what's the status of the RSC, short circuit current, and also the VOC of the PV modules. So they can use the string inverter to the IV scanning functions. That we can generate a table of each PV strings. What's the VOC and what's the RSC right now? So what's the health of the PV module right now? So Sungrow can also package solution for the SCADA system of the online SCADA system, which name is ISO Cloud. By using the ISO Cloud and the inverter together, we can have the online IV curve scanning function, and that we can diagnose the PV modules anytime you want. And so maybe some friends will ask if we are using the IV curve scanning function, will it influence the power generation in the system? Because when we are working with IV curve scanning function, the MPPT point of the inverter will be moving from time to time to do the diagnosis of the PV modules. But for each inverter, a single inverter, we can finish the scanning within 20 seconds. So in the below part of this slide, we showed 15 minutes. So for 15 more minutes, the most time of 15 minutes, they are update the data from logger to the SCADA system. Actually, for inverter itself, the scanning time for IV curve is only 20 seconds. So it only influences 20 seconds of the power generations. And you don't need to scan the PV modules very often. Maybe after every 6 months or 3 months, you scan the power station for one time. So for IV curve scanning function, it won't influence the power generation of the system a lot. And this is a system architecture of the PV station for our utility projects. You can see here, from the below part is a PV station where it has inverter, base station, transformer. All of them we can use 100 to send it to the SCADA system. And for Sungrow side, we can package solution for SCADA system. It has two parts. One is local SCADA. The name inside system is a SCADA for operators for daily management in the site. And we also have some remote SCADA for ISO Cloud, which can access anywhere by laptop or cell phones if you have the internet. So we can package solution is two SCADAs together. And regarding the PPC, power plant controller, we are cooperating with some third-party manufacturers. And so that in this way, we can package solution PPC as well. So the reason why we provide the PPC at the same time, because so if a PPC supplier and inverter supplier have not been working together before the commissioning of the site, maybe in the site it will cost you a lot of time for commissioning between PPC and inverters. We don't want to cost much time for commissioning, so we do the pre-test from PPC to the inverter in Sungrow workshop. that we prove that the PPC we provide, it can work with Sungrow inverter together. So this is the reason why Sungrow we can package solution for PPC and inverter. And at the right side, it shows a plan scatter. So normally for a utility project, it will has the grid connection voltage like 132 kilowatt or 110 kilowatt. It will have another substation that is HV station. So in this way, it will need an individual plan scatter for HV stations in the system. For this plan scatter, it's not in Sungrow scope, but we can recommend with you some supplies in the system. So this introduce the typical communication system for a PV station. And if you need some detailed information, please send an email to us. We can discuss with you with the detailed things for this graph. And regarding the grid support side, we can see here on the left side for Sungrow inverter, we can adjust the power factor from 0.8 lagging to 0.0 lag leading. And that means that for Sungrow inverter, for SG250HX, its apparent power is fixed. And no matter you want it to work at which point inside this table, like 0.9, 0.8, 0.95, even 1, it can work at any value you want. And the active power and ready power capability will be adjusted from power factors to power factor. So, but no matter which point it works, the apparent power is fixed. The 250 kVA is max capability of apparent power. And regarding the same times, and the inverter can also be compatible with Twoinone function. The inverter can use the grid power to generate some ready power at night to do the compensation of the ready power consumption at night, like transformers and cables at night. So if you don't have some compensation of ready power at night, maybe you need some penalty from the grid operators. But you can use the inverter to do the compensations of ready power at night to reduce some cost of the ready power. And we also compare with some with this inverter and other inverters. What's the difference between O&M cost, the CAPEX cost, and the we can see here we divide into different parts of the O&M cost, from the mechanical inspections, cleaning, electrical inspections, and repairs, and we also divided it into 2 parts, 1 to 5 years and 6 to 25 years. And you can see here how much money you can save. So, and after 25 years, in general, we can save around $0.4 million by using the 250 kilowatt inverters. And if we are using another inverter like 185 kilowatt inverter, maybe it will have a higher cost for OPEX for 25 years. And if you have interest, we can send it by email with compare table. And the first chapter of this slide is the high yielding, which is very important for the inverter. So first, we compare some difference between bifacial modules and single facial modules. First, the bifacial modules will have some reflections from the ground. That means that different strings will have different MPPT features. In this way, it's very important for inverter side, which has a higher quantity for the MPPT. So at the same time, we need to configure the inverter with a higher current capacity. So this is the reason why Sungrow inverter, and we are configure each string capacity with 13 amperes. So not maybe the bifacial modules here has like 10 ampere or 11 amperes. This kind of high current value, but no matter how high it is, we can cover with the high bifacial module requirements. At the same time, our boost, every 2 strings will has 1 boost for MPPT. So boost current is 26 ampere, which can also cover the requirement of the bifacial modules. And by using the 2-in-1 design, it shows how to achieve a very high discharge ratio if you want. We want 1.4 or 1.5 discharge ratio. We use the Y connectors in the below part of the system. The 2 strings connect to 1 connectors outside of the inverter. Maybe below the PV modules and use 6 mm square cables to send the power to each connector of the inverter side. So that each connector of the inverter side we can connect 2 strings at the same time. In this way, maximum string connection quantity for this inverter, we can connect 36 strings at the same time. And at the same time, now the PV modules is becoming larger and larger, maybe 380 watt or 390 watt. In this way, I think 36 strings connections can cover maybe 99% of the size requirements, no matter how high the DC ratio requirement it is. And this page introduces how the inverter will protect the PV modules from PRD phenomena. You can see here because like we already discussed, the string inverters can't use the negative grounding same as the central inverter, because multiple string inverters will connect to the single winding of the transformer side at the same time. So we can't use the negative grounding. Otherwise, it will have some short circuit in the system. In this way, Sungrow has a pattern by ourselves that we have a PRD circuit at the AC side in the system, like we see here. I use some plans of this system. So we can see in the red cycle, this is the PRD circuit on the AC side of the inverter. That we will elevate the AC side voltage of the inverter, because we know that now the inverter is not a isolated system. So if we increase the DC side, AC side voltage, the DC side voltage is also increased at the same time. In this way, the PV module voltage from PV modules to ground is also increased. Finally, we can achieve a higher voltage value from PV modules to ground. If the voltage between PV modules to ground is a positive value, we can protect the PV modules from PRD phenomena. And at the same time, Sungrow is the only one manufacturer for PV inverter that will provide the PRD protections and the PRD recovery at the same time. So what is PRD recovery and what is anti-PRD? So anti-PRD is the protection for PV modules at the daytimes, but at night time, if the PRD happens, some PRD already happens for PV modules, we can use the PRD recovery that we send some revised voltage from inverter to for the PV modules that we can repair the PV modules, which already been influenced by the PRD phenomena. On the right side, we shared some data from the real side. How much power we can get from the modules that we use the PRD recovery function to repair it. We can see here some PV modules already be degraded because of PRD phenomena. After several months of PRD recovery and the PRD repair, the yield is increased by 10% from the original data, because we use the revised voltage to repair the PV modules. And Sungrow, we are the only one that we integrate the PRD circuit inside the inverter. We don't need to purchase some additional PRD box or some devices inside outside of the inverter. We already package solution and integrate this circuit, this technology inside inverter, so that it's plug and play. It's working automatically after commissioning, and we can save your time for commissioning and your investment for some separated individual PRD box. Okay, let's come to the next page. And the last part, we will introduce some reference of Sungrow inverters. And so this is the last year data. So up to 2018 December, Sungrow already has 79 gigawatt installations of PV inverters. And this year data, we already has 82 gigawatts reference of PV inverters up to this year, March. So we will update our data in the next several months of the first half of 2019. And our headquarters is in China, and also has many companies or some offices in all the major PV markets in the world, like USA, like Germany, like the Australia and other countries in the world. We have already, if we can see here. So in general, only in Russia and some north regions that is not suitable for solar industry. Other countries will also already has many offices. Please contact our sales manager in your country for the further business. And these are some case reference. So in Ukraine, it's very cold inside, so it's -30 in the side, and in some China, Sichuan province, it's more than 3 kilometers for the altitude, because in the high altitude it's a challenge for the cooling for the inverter. But we already have many reference here in China western areas which have a very high altitude. And on the depth below side is the high humidity reference, which is located nearby the sea. And our inverter already has many reference in some countries nearby the sea, like Philippines, like Malaysia, and Vietnam. There are many references in these countries. And in the right below side is high temperature. So for Sungrow inverter, we are designing inverter with a very high temperature derating capability, so that we can guarantee in some tropical areas there's no derating from the inverter side. So no matter you are using the installed inverter in India or Middle East or other countries which is very hot, we can guarantee in summer the inverter has no deratings, so that we can have a higher power generations. Because if inverter you are derating at 30 degree or 20 degree, you will lose much of the energy you can get because of inverter derating. So this is the reason why all Sungrow inverter we can have a very high temperature capability for the inverter side. Okay, that's all. Thank you to see our slides. So let's come to the Q&A part. So maybe if you have any questions, please just tap here. I will see your questions and answer a question one by one. So okay, I see the question from Lawrence Chao. What's the recommended range of transformer megawatts? So now for Sungrow, we are recommend to use the 6.3 megawatt of the transformer for single block. But I want to say that the block size of the transformer is according to the site condition. If some sites the land is very complicated, maybe you are using you better use a 2.5 or 5 megawatt block. So it depends by different case to case. But if the site is very flat and you want to lower the system cost, and we do some calculations from different block size, from 5 megawatt blocks, 6 megawatt block, that we finalize the 6.3 is the best, is the most beneficial solutions for our system. This is the reason why we are using the 6.3 megawatt transformer for a single block. I hope I answer your question well. And second question is also from Lawrence. Is PPC supplied by Sungrow or third party? So it's third party. We're cooperating with some PPC suppliers. So in this way we package solution for PPC together to guarantee the PPC can working with Sungrow inverters in the site. We don't want to cost much time for the commissioning between PPC and the inverter in the site. Otherwise, it will be very tricky for commissioning. So this is the reason why we are cooperating with third-party suppliers for the PPC. And next question is also from Lawrence. Is local SCADA and plant SCADAs are supplied by Sungrow? Yes, local SCADA is supplied by Sungrow, but for plant SCADA, for HV SCADA, we are not covered that side. There are many suppliers which are dedicated in these areas. We can give you some suggestions if you want for plant SCADA. But for Sungrow, we can package solution for local SCADA and with the inverter together. And the next question is also from Lawrence. Is the inverter model available for power flow analysis? So regarding the system power flow analysis, we already have PSG model and also has the P-SCADA model as well. So normally for a system designer, you will need the PSD or PSCAD or the Power Factory models for do some simulations for the power flows. We can give you the inverter model for the simulation formula, and maybe you can put it in the system model so that you can get the simulations for the system level power flow analysis. And next question is from David. What is better? Which one is better from central or string? Central or string inverter? It's a very interesting question because for Sungrow, we both has the central and we can also provide string at the same time. And in general, the central can save you much time, not much POS cost for the system cost, because as long as the line is flat, because we do some calculations and simulations inside. If the site is flat, if you because for central normally it's only one MPPT, central string inverter has many MPPTs. So as long as the site is flat, the power generation will be similar for central and strings in the flat area. So in the flat area, we recommend to use a central inverter to have a lower system cost. At the same time, if the central inverter, if you are using a central inverter, it has less quantity for these inverters, because for central inverter, maybe for 100 megawatt projects, maybe you will only has around 30 numbers of inverters. But for string inverters, you will have maybe 1,000 or 100 of string inverters. If a grid operator, they are sending a command to site. So with the huge quantity for string inverter, it's very difficult to do the commands from grid operator. The response time for string inverter is very high. But for central inverters, it has less quantity. It is easier for you to do the response from the grid operators. So the central has their advantage, and string also has their advantage at the same time. So it's case by case. We recommend central and strings. Depends by your site requirements. Maybe each site we can give you some suggestions if we want. And Lawrence has a further question. So max 6 megawatt is recommended. It is his question. So if according to Sungrow calculation, yes, 6.3 megawatt is a very beneficial and most cost-effective solutions for the system level. So we can recommend 6 megawatts or 6.3 megawatt solution for most cases. And in some countries, maybe they have some special requirements for the transformer and switchgear. So in this way, maybe the large block is also better. So we have seen some 12.5 megawatt block in some countries. But for most countries, we think 6.3 megawatt is the most cost-effective solutions for each block. And next question is from TT. So the question is about stream monitoring and analysis. Is it separate price or included? Thanks. So it is a question. So for the answer, for stream level monitoring, it's inside of the hardware of the inverter. So it's a part of the inverter price. But regarding the analysis, it's a part of the SCADA system, the remote SCADA system. So the analysis is a part of the SCADA cost. So in this way, we separate the cost from stream monitoring is inside of the inverter, and the analysis inside of the SCADA. So it has two separated price for inverter and SCADA system. Maybe you can contact our commercial team for the further quotation for these functions. And next question is TT. Can you share these slides? Yes, of course, we can share these slides after the webinar. And I also attach our my email address here. And this is my email address. So maybe you can send an email to me, and I can send you by email for this slide. Next question is from David. Are you monitoring voltage, current, energy in the MSI? Would you be interested? So okay, it's a very interesting question for the system design. So and first, because in the system it has different layers different lines of the system. Maybe from the MV side, it's up to 33 kV, but in the site, maybe it's 132 kV. For the revenue meters, is installed at the point of interconnections. So if the site is 132 kV connection, so maybe the revenue meter is installed at 132 kV side. If the system is 33 or 36 kilowatt for grid connection, the revenue meter will be installed at 33 kilowatt side. So it depends by requirements. But at the same time, some customers, you want to monitor each block, each MV block, voltage, current, energy from time to time. You want to monitor it. If you want to monitor it, we can install some meter at the switchgear or IMU. They need a separated cabinet for monitor it. Yes, we have a solution, but it needs some customized design. Maybe we need to design the switchgear or IMU. Depends by the system. So yes, we have solutions, but it's not in the standard quotation. It's not in standard solutions. If we want, we can talk about it case by case. And I see all the questions. I don't know if you have some further questions. If you have some further questions, please just type here. I will answer your questions. I see some other questions in the Q&A part. So I see some question from Mr. Dio. Yeah, he asked about some detailed design from fuel modules and the string inverter. So yes, definitely Sungrow can help you for this system design. And I think this kind of detailed requirements we can answer after the webinar. I will send you an email and give you the detailed design, and I will contact you after the webinar. And the question from Mr. Alokin, and will you send the materials afterwards? Yes, we can share after the webinar. My email address is here in the slides. Please send an email to me after the webinar. He also has a further question. What is the maximum cable length for power line communication, for PLC communication? So actually, first I want to clarify that the PLC doesn't need the cable. So this is the reason why we are using the PLC to save the cable cost. And regarding the PLC maximum communication distance, it can maximum support 1 kilometer from inverter side to the transformer side. I think it can meet 99% of the site requirements. So 1 kilometer is the answer. And I see some further questions. Sorry, I need to check it. And 1 minute. Okay, so I see a further answer from Mr. David, and yes, it has some additional sensors at the switchgear side, and we can configure its design, and it's a customized design, and we can contact you after the webinar. So please send an email to me. And another question from Mr. or Miss TT to me. What is the Sungrow global target to 2019 gigawatt? Can you beat Huawei this year? It's a very challenging question, because we know that Huawei and Sungrow is very competitive in the industry. So I want to say that in the last past 3 years, we are the #1 of the shipment of the inverter annual shipment volume in the inverter industry. I think this year we are target around 19 to 20 gigawatts of the inverter this year, and I think we can maintain our position in this industry this year. And another question from Mr. Liu. What is the central inverter you may recommend for 3 megawatts peak? So because 3 megawatt peak is the DC side, so it will depends by what is the DC ratio in your country. So if our country, in some countries like Japan, not Japan, like China and Korea, they are still using the 1 and 1 DC ratio. So for 3 megawatt peak, you are using 3 megawatt inverter. But in some countries, you are using 1.2 or 1.3, even 1.5 DC ratio. So it will depend by the DC ratio that of the system of this country. So maybe we can give you a detailed recommendation after the webinar according to site and the specific country requirements afterwards. Please send an email to me. I will answer questions. So may I know any other questions? I didn't see some further questions. If you have questions, please just type here, no matter in Q&A or in the chart of the system. I can see that. Okay, I see another question. The question is, any next accessory for PLC needed for log 3000? Okay, it's like this. So inside of log 3000 is a PLC receiver. Yes, it's an individual component inside log 3000 is a PLC receiver. So, but the PLC receiver is already inside of the log 3000. So you don't need some additional accessories for PLC communication. We already integrated in the log 3000, and log 3000 is a part of the CAM100. So we can package solution for our standard configuration of CAM100 for achieving the PLC communication. So it's not needed for other accessories for PLC communication. So may I know any other questions? Okay, a further question from TT. The question is, what is the standard warranty for inverters and for transformer stations? For string and central inverter are the same warranty. Okay, here is the question. So here's my answer. So for Sungrow side, our standard warranty is 5 years for inverter and transformers. And for central and string, they share the same warranty policy from Sungrow. So no matter central or string, we have the standard 5 years warranty. And we are flexible for have a longer time of the warranty, maybe 10 years, 15 years, or even 20 years. We can give you these quotations for further warranty, but standard warranty is 5 years. If you have some interest for a longer warranty or warranty extension, we can give you some quotations if you want. So may I know any further questions? I can answer your questions. Okay, question from TT. Do you have local office in Ukraine? So office, because I'm in the Asia Pacific region, and Ukraine is belong to our European team. So I think we can contact you with our European team for the further business. I think we have the sales manager for Ukraine, but I don't know he has an office or not in Ukraine. So for this question, sorry, I don't know, but I can give you some context for our commercial manager for Ukraine. I can give we can share some further information. Oh, and since we don't have some further questions, but I would like to introduce some status of this inverter, this 250 kilowatt inverter. And for your information, we already got all the IEC certifications, no matter for safety, EMC, anti-islanding, or efficiency, or environmental certifications. We already got all of them for IEC certification, which is issued by TUV. and it's available right now. And if you have interest, we can share by email by email. And for this inverter, we have different versions because of standard side. We have one version for IEC region, another version for UL region because of standard side. So the IEC certification is already be done, and for UL certification, we will get it in around in October, I think. So in this way, the certification is not an issue for this inverter. Before the inverter manufacturer, the certification of the inverter is already ready. Okay, another question from Mr. Alokin. And when the inverter will be available on the market? Okay, for us, I already introduced the inverter for IEC region will be available within around 2 or 3 months. So I think in end of September or early October will be available for manufacture. But maybe I suggest if you have a project, maybe you can issue the contract or PO before the manufacture. So after the inverter manufacturer is ready, we can do the manufacture at the first time. And because now Sungrow will have many strict regulations for testing internally to guarantee the inverter reliability after releasing to the market. So now the inverter is at the final stage of the testing in our R&D right now. It will be finished within 2 or 3 months. Okay, I see. Okay, I see another question from TT. Do you have any US material or SW inside the product? So okay, so I see this question. So because it's a very hot topic right now, because we know the U.S. government has some policies towards the products from China manufactured. I want to say that so Sungrow, we have more than one factories. We have a factory outside of China. We can have a manufacturer outside of China, so that we don't have the issue for the tariff from USA market. So, and I think we can contact with you for in the future if you have a USA project. I hope I answer your question well. Okay, thank you. And if you don't have further questions, we will close the webinar within 5 minutes. If you have further questions, please don't hesitate to send an email to me. Okay, thank you very much. Bye. Bye, Novice. Bye, Mr. Alokin. Okay, thank you as well. Okay, thank you very much for being a part of this webinar, and it's my great pleasure to share our knowledge about this new inverter to you. And I'm looking forward to contact you in the future for further discussions related to the projects or the inverter. So, and my email is here. Please send an email to me if you have any requirements for inverter discussions. So I think today we can finish the webinar right now, and have a good night, and okay, bye-bye. See you next time.